Now about form of energy. As I defined earlier, energy of an object is its ability to do work. You all are familiar with different kind of source of energy. Different kind of energy is available to do different kind of work, like kinetic energy, potential energy, chemical energy, electrical energy, light energy, etc. So we will discuss in detail about all of them one by one. So first about kinetic energy. By definition, kinetic energy is the energy possessed by an object due to its motion. Now take the example of the ball hitting the wicket or the hammer striking the nail. What is happening there? The ball hitting the wicket, doing some work and making it thrown away. The hammer has got some energy and striking the nail and pushing it in. So what kind of energy they have got? They have got kinetic energy. They have got that energy because of their motion. Think of a stationary ball. Can it blow away the wicket? No, it cannot. Think of the stationary hammer. Can it push the nail inside the wooden block? No, it cannot, because they don't have energy when they are not moving. So we can say object in motion possess some energy, okay, like the ball, the moving ball, or the moving hammer. That kind of energy is known as kinetic energy. Now, very simply, we can say the kinetic energy of the moving object increases with speed. If the ball is moving with higher speed, its impact will be more. If the ball is moving with lower speed, its impact will be less. Means work done will be more or work done will be less. So its ability, its capacity to do work is more or capacity to do work is less. We can think of many examples where kinetic energy and the speed we can think of. One stone hitting a glass panel slowly will not break it, but the same stone hitting the glass panel with high speed will break it. So what is the difference there? The work done is different. The capacity of their doing work is different. Their energies are different. So the higher the speed, the higher the energy. Lower the speed, the lower the kinetic energy. So there are few examples of kinetic energy. You can see a rotating wheel, flowing water, or flying aeroplane. All have got kinetic energy. And now we will see the derivation of kinetic energy, how we can calculate kinetic energy of a moving object. Now here we will try to derive out how much kinetic energy a moving object will have if its velocity is v. Kinetic energy of a body moving with certain velocity is equal to the work done on the object to make it acquire that velocity. In the discussion about energy, we said energy of an object is its ability to do work. So how much work is done on the object will be its energy to do work. And here the work will be done to give that object that velocity. So the work done on that object to give that velocity will be equal to the kinetic energy of that moving object. So to find that out, we will use few formulas. Simply, we will start with the work done on that object. Let's say m is the mass of the object, s is the displacement given to it by a force F Newton. So by definition, W is equal to F into S, and if U is the initial velocity, V is the final velocity, and A is the acceleration due to force F. So mass, displacement, force, initial velocity, final velocity, and acceleration. So with this we can say force applied on that object to give it that velocity will be m into A. This we know by the definition of force. And using the third equation of motion, we know that v square minus u square is equal to 2as. We will use these three relations. S is equal to v square minus u square upon 2a. Now we will put the value of F and value of S in this equation. to find out the work done. So we will find work done will be m into a into v square minus u square upon 2a. These two cancels, so it becomes 1 upon 2m v square minus u square. So here we can say this is the work done on that moving object of mass m to gain velocity from u to v is defined with this relation. And by very definition of energy, we can say this will be the energy possessed by that object which is moving with from this velocity to that velocity. By very definition, work is equal to energy. This much work is required to give that object velocity v. So this will be the energy as well, because work done is equal to energy because of its motion. So we can say kinetic energy of that object will be 1 upon 2m v square minus u square. And if we take a situation where u is equal to 0, the object has started from rest. So kinetic energy of that object will be nothing but 1 upon 2 mv square. So here also again you can say if v is more, if the object is moving with higher speed, it will have more kinetic energy. If v is less, the object is moving with slower speed, it will have less kinetic energy.